हेलो एवरीवन। इसमें हम कवर करेंगे कि सॉलिड लिक्विड और गैस की प्रॉपर्टी कैसे होती है, और वो भी थ्रू एक्टिविटी। ये एक्टिविटी आप घर पे भी करके देख सकते हैं, विद योर टीचर भी करके देख सकते हैं। सो फर्स्ट एक्टिविटी, कलेक्ट द फॉलोइंग आर्टिकल्स लाइक ए पेन, ए बुक, ए नीडल एंड ए पीस ऑफ वुडन स्टिक. Sketch the shape of above particle in your notebook and moving a pencil around them. Do you these have a def- definite shape, distinct boundaries, and a fixed volume? What happens if they are hammered, pulled, or dropped? Are these capable of diffusing into each other? Try comparing them by applying force. Are you able to compress them? But this is answer no, because all those articles uh, we will be collected, so the form of a solid, so we can't in compressed, right? All the above are examples of solids. We can observe that all these have a definite shape, distinct boundaries, and fixed volumes, that is have negligible compressibility. Solids have a tendency to maintain their space when subject to outside force. Solid may break under force, but is difficult to change their shape, so they are rigid. So this is the type of solid properties. So you can note down. Consider the following, like what about a rubber band? Can it change its shape on scratching? It is a solid. What about sugar and salt? When kept in different jars, these take the shape of the jar. Are they solid? What about a sponge? It is a solid, yet we are able to compress it. But why? Because in mixed up in liquid shape, so types of solids. All up, all the above are solid, as a rubber band change shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. The shape of each individually sugar of salt crystal remains fixed whether we take it in our hand, put in a plate, or in a jar. A sponge has minute holes in which are in which air is trapped. When we press it, the air is expelled out and we are able to compress it. So these are the reason of fine, right? And now we will study the liquid state. Collect the following articles like water, cooking oil, milk, juice, a cold drink, and containers of different shape. Put a 50 ml marks on these containers using a measuring cylinder from the laboratory. What will be happen if these liquids are split on the floor? Measure 50 ml of any one liquid and trans it into different container one by one. Does the volume remains the same? No. Does the shape of the liquid remains the same? No. So this question we will be find out answer in below. We observe that liquid have no fixed shape but have a fixed volume. They take up the shape of the container each which they are kept. Liquid flow and change shape, so they are not rigid but can be called fluid. Refer to activity 1.4 and 1.5, where we saw that solid and liquid can diffuse into liquid. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are initially for the survival of aquatic animal and plants. All living creatures need to breathe for survival. The aquatic animal can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solid, liquid, and gases can diffuse into liquid. The rate of diffusion of liquid is higher than that of solid. This is due to the fact that in the liquid state particles move freely and have greater space between each other and compress to particles in the solid state. And next type of the gaseous state. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? Inquire from him how many balloons is he able to fill from one cylinder. Ask him which gas does he have in cylinder. So in cylinder, hydrogen gas so used because very light, very light gas. Take 300 ml sirens and close the air nozzles by rubber ropes as shown in figure 1.4. Remove the pistons from all the sirens, leaving one siren untouched. Fill water in the second and pieces of chalk in the third. Insert the piston back into the siren. You may apply some Vaseline on the piston before inserting them into the siren for their smooth movement. Now try to compress to contain by pushing the position in each spring. So you can show also a piston, and you also see in a syringe, right? This is the syringe and rubber choke, gas and piston. And what do you observe in case which case was the piston easily pushed in, and what to infer from your observation?